Introducing Python. Okay, so in this course, you're going to learn everything you need to get started with geospatial programming using Python. This class is for students with little or no programming experience, and the content is going to reflect this beginner status. We'll be going over concepts throughout the semester that are fundamental to programming. Advanced topics and applications are beyond the scope of this class. If you already have programming experience, you may find that this class is not challenging enough. Consider enrolling in Geospatial Programming 2 instead. Geospatial Programming 2 is taught by Jim Graham during the fall semester at HSU. Throughout my videos, I'll be using this virtual blackboard. I'm handwriting this as I go, and I'm a terrible speller, so I want to apologize in advance for any misspelled words. So what is Python? Python is a simple and powerful programming language. It's popular among software developers, data analysts, mathematicians, and geospatial scientists. Python has several features that make it the programming language of choice for working with GIS. First, Python is considered a high-level programming language, and because of that, it's easy to learn. So what do I mean by a high-level programming language? High-level programming languages use code that is easily understood by humans because it uses a lot of English words. On the flip side, high-level programming languages are hard for computers to understand. They need to be converted into a machine language. You do this by either interpreting the language or compiling the language into something a machine can understand, like a series of ones and zeros. These types of languages are called low-level languages because they work more closely with computer hardware. There's a whole spectrum of languages ranging from high-level to low-level. High-level languages are easier to learn because they're closer to human languages. The drawback is that high-level languages are slower than low-level languages because of the time it takes to convert it into machine language. Now, when compared to other high-level programming languages, Python has another advantage. It has uncomplicated syntax. This means that it can solve complex problems in less time with fewer lines of code when compared to other highly structured programming languages. This allows you to spend less time struggling with the code and more time writing it. Python is also cross-platform. This means that it's supported in Windows, Android, macOS, and Linux. In fact, for the first half of the semester, you'll be able to work on assignments directly on your personal computer, even if it's not running Microsoft Windows. During the second half of the semester, you'll be using Python with ArcGIS Pro, which only runs on Windows. At that time, you'll either need to use computers on campus or use the HSU virtual machines. I'll talk more about that when the time comes. Until then, you'll be free to use a computer that runs on any platform. There's one caveat though. I think Chromebook users might have a harder time installing many of the applications that we use in this class. I know it's possible to install a version of Linux on Chromebooks, but I don't know any of the details. For that reason, if you're using a Chromebook, you should consider taking advantage of the HSU virtual machines unless you feel confident figuring out the workarounds. Python is an interpreted language. As I mentioned earlier, high-level programming languages require that a program be converted from the source language into binary code that the computer can understand. Often this conversion requires a compiler. The way a compiler works is that you first write the source code. For example, if you wrote A equals 3, B equals 10, C equals A plus B, print C. The computer can't understand this. So you use a compiler to convert the source code into machine code, a series of ones and zeros. It's only after the code gets compiled that the code is executed, passed into computer memory, and returns a result. In this case, it would be 13. The entire source code needs to be compiled before the code gets executed. However, Python is an interpreted language. That means it uses an interpreter rather than a compiler. So what's the difference? An interpreter is installed on your machine beforehand. From that point forward, it can make the conversion directly from the source code. Instead of compiling the entire code all at once, it translates into machine code on the fly, one line at a time. So take our previous example. You enter A equals 3. The computer interprets and executes that line immediately. Then you enter B equals 10. The computer interprets and executes that line immediately. C equals A plus B. That line of code gets interpreted and executed, and the result of the calculation gets stored in memory, and so on. Python is also an object-oriented programming language. In programming, an object is an instance of a class, a collection of data structures and functions working together as a unit. Think of objects as virtual toolsets and classes as the blueprints to make those tools. You'll learn more about classes, objects, data structures, and functions later in the class. For now, all you need to know is that object-oriented programming has certain advantages because it uses a collection of interacting objects to solve problems rather than a typical list of tasks. One of the best things about Python is that it's free and open source software, and it's been around for over 20 years. It has a huge community and a large ecosystem of libraries, frameworks, and tools. Python was not created specifically for geospatial science. It has broad applications, including web apps, games, automation, and machine learning, to name a few. We won't be exploring many applications outside of geospatial science. You'll learn the fundamentals of programming with Python and an introduction to its geospatial applications. That said, you shouldn't think of the skills you learn in this class as limited to only geospatial science. Because of its versatility, you'll be able to take these skills and use them for other tasks as well. Scripting versus programming. Now, I've said that Python is an object-oriented programming language. However, many often refer to Python as a scripting language. A scripting language refers to automating certain functionality within another program. For example, ArcGIS Pro provides support for the use of Python as a scripting language. Python can access all of the tools available in ArcGIS Pro, including those that are part of an extension. This feature makes Python scripting an attractive and efficient method for automating tasks. Alternatively, a programming language involves the development of more sophisticated, multifunctional, and standalone applications. Programming allows you to build components from scratch, as well as the applications that incorporate these components. Esri, for example, relies primarily on C++ as the programming language to create ArcGIS Pro software and all the different components or objects that you find in the software. Python, therefore, is both a programming language and a scripting language. In this class, you'll be using Python as a scripting language. The focus here is to carry out tasks in ArcGIS Pro, as well as extending the existing functionality. Python version 3. Python has gone through a limited number of versions, reflecting a philosophy of incremental change and backward compatibility. Python 2 was introduced in 2000, and the final version is 2.7. With every revision, new features were added, and over time, some inconsistencies and design flaws crept into the code. Python 3 was released in 2008 as a major overhaul, with the primary goal to clean up the code base and remove redundancy. Unfortunately, not all code in Python 3 will work with Python 2. You can find the most recent version of Python 3 at python.org. However, when you install ArcGIS Pro, it automatically installs a version of Python 3. And in this class, I will focus solely on teaching Python 3. Installing Python. First thing you need to do to get started is to install Python on your computer. Okay, so you might be wondering, if Python's a programming language, why would I need to install it? Well, what you're actually installing is an interpreter for Python. We're not going to really go into detail on what that means, but just know when you install this interpreter, it allows your computer to understand and run Python code. As I mentioned before, if you have Arc Pro installed on your computer, then you already have the Python interpreter installed. If you don't, then the first thing you need to do is to open up your browser and head over to python.org. On this page, just click the downloads link to take you to the downloads page, and there you'll see a number of different options to download. So I have a Windows computer, so I'm going to click the download for Windows. After the installer downloads, I just double click on it and follow the instructions. Now, because I have Arc Pro on my computer and I already have Python, it's actually prompting me to upgrade rather than to install. So I'm just going to go ahead and do that. While you're watching this video, there's a good chance that there's going to be a newer version of Python available. If there is, don't worry about that. Everything in this course will still apply. If you have a Mac computer or Linux, you can use the links provided and read any documentation for installation. I don't have access to a Linux computer or Mac, so you'll have to kind of figure that out on your own. If you have a Chromebook, there's plenty of tutorials on how to do that as well. I think there's two options. You can install Linux on your Chromebook, or PyDroid 3 is a good app that you can get from the App Store that'll also install Python on your Android device. And that's pretty much it for installing Python on your computer. Code editors. All right, so now that I've covered installing Python directly from python.org, I'm going to talk about code editors. A Python file is basically a text file. You can actually use any text editor, such as Notepad, to edit Python code. However, a better option to edit code is to use an integrated development environment, or IDE. Oh, by the way, I'm a terrible speller when I'm writing by hand, so I apologize in advance if I misspell words. Okay, IDEs have additional features to make writing code easier. So a good analogy would be using Microsoft Word to write a long document. You could use Notepad or another text editor to write long documents, but I bet you wouldn't enjoy it. Microsoft Word or even Google Docs has additional features that make composing long documents easier. IDEs work in a similar way. They have features for editing, debugging, and testing your code. There are tons of IDEs, and everyone has a favorite. In this class, I would like you to use Jupyter Notebook, a popular application for data science and visualization. Jupyter Notebook is an open source web application. It's unlike a traditional IDE, but it does provide an intuitive and interactive way to write and run code. I find that Jupyter Notebook is ideal for teaching Python as well. Jupyter Notebook works on Mac, Linux, and Windows. If you have a Chromebook, I recommend that you use the HSU virtual machines, which already have Jupyter Notebook installed. To install Jupyter Notebook, go to anaconda.com. From the Products menu, choose Individual Edition. And when you install Anaconda Individual Edition, it installs a toolkit that includes Jupyter Notebook and some useful libraries. It also installs the latest version of Python. So technically, you didn't have to install Python directly from python.org. if you're installing Jupyter Notebook, but I did want to show you how to do it. So now I'll walk you through the installation process. Click the download button and choose the correct installer for your operating system. I'm using Windows, so I'll choose the Windows installer. I'll go to my downloads folder and launch the installer file. When the setup window opens, just follow the prompts. I recommend that you accept all of the default options unless you have previous experience. Now, if you only have Chromebook, you'll need to use the HSU virtual machines. The good news is that you don't have to install anything. The virtual machines have all of the software you need for this class. To use the virtual machines, open a browser and go to vlab.humboldt.edu. If you've not recently signed in, you may have some additional steps to complete. You'll need to sign in with your HSU Gmail and password, and you may need to verify. If you're having trouble logging into VLab, you should start a help ticket with the HSU Help Desk. You can do that by emailing help@humboldt.edu, and they should get you sorted out. Once you're in VLab, click the desktop icon. What you see here is a virtual Windows computer within your browser. It doesn't use any of your local hardware, so if you have a slow computer, it shouldn't matter. The only thing your computer provides is your keystrokes and mouse clicks transmitted over the internet. You can access Jupyter Notebooks by pressing the Windows key and entering the word Jupyter, spelled with a Y. Then you can launch the app from the Start menu. There are a couple things about VLab that you should know. The virtual computer is temporary. If you log out, there is no guarantee that your files will be there the next time you log in. For that reason, you need to back up any files you create in VLab to the cloud. I recommend using your HSU Gmail account to upload a copy of your work to Google Drive. Be sure to do this every time you are ready to log out. The other thing you should know is that during the semester, there are times when a lot of the students are using VLab at once. In a typical semester, there's about 500 or so students taking geospatial courses. Rush hour tends to be in the evening on the day that assignments are due. As a result, you may find that on certain days, VLab will run slower. It varies, but Friday and Sunday nights tend to be busy. If you plan to use VLab, then I recommend that you try logging in at different times to see when you have the best performance. Exploring Jupyter Notebook. For this next segment, I would like you to follow along. The best way to learn any new language is practice. Python is no exception. Either on your personal computer or on VLab, open Jupyter Notebook. On launch, it opens a terminal window, and then it opens your default application for HTML files. Typically, this will be your default web browser. In this instance, it's using Edge, and it's running a local server called localhost 8888/tree. If you don't know what that means, that's fine. It's not something we cover in this class. All you need to know is that even though we are using a web browser, most of what we are about to do is happening on a local computer rather than on the internet. You can see this activity on the Jupyter Notebook terminal window. Be sure to leave this terminal open as you work. On your browser, you should see a dashboard with a list of directories and files on your computer. Your computer may look a little different than mine. The root directory will be the same location where the Notebook server was launched. Because I used the Start menu to launch this application, it defaults to my user account directory on the local hard drive. You can find this information on the terminal if you need it. Now, I'm going to show you a different way to start Jupyter Notebook so that you can specify the root directory. As you may have already learned in previous geospatial courses, file management is extremely important. Go back to Jupyter Notebook on your browser and click on the Quit button. In this next step, you're going to use another terminal window called Anaconda Prompt to start Jupyter Notebook server in a folder on your desktop. First, let's make a new folder on the desktop called GSP-318. Make sure there are no spaces in the name. If you're working on the HSU virtual machines, it's especially important to work on the desktop to avoid unexpected problems with administrative permissions. Depending on your operating system, there will be different ways to open Anaconda Prompt directly. For the sake of simplicity, I'm going to show you how to do it with the Anaconda Navigator application. Locate the Anaconda Navigator on your computer and start the application. On Windows, you can press the Windows key and type in Anaconda to find it. Here you can see the applications that were installed with Anaconda. Locate the application titled cmd.exe prompt and open it. Once it opens, you can minimize the Anaconda Navigator. Okay, so I want you to take notes for this next part. It's something that you'll have to do repeatedly when starting your assignments, and I want you to feel comfortable performing these steps in the future. When the command line terminal window opens, you'll see the base directory where Jupyter Notebook will start. To change it to the desktop, type in cd desktop. CD stands for change directory. Then press enter. You should see that the base is now on the desktop. Next, type in cd GSP-318 and press enter. Okay, so now you're ready to launch Jupyter Notebook. On the next line, type Jupyter Notebook and press enter. When Jupyter Notebook opens in your browser, you'll see the contents of your GSP-318 folder on the desktop. Because we haven't added anything, it should appear empty. Let's check the Notebook terminal to make sure that the root directory is GSP-318. You should see a line that says serving notebooks from local directory, followed by a file path to your GSP-318 folder. Okay, back to Jupyter Notebook. I'm going to maximize the window and zoom in so that you can see what I'm doing. You don't have to zoom in on your computer. Let's start by making a new folder. On the right, you'll see a button that says New. Use the drop-down menu and choose Folder. You'll find the new folder in the list. It's called Untitled Folder. Check the box next to it, and then click the button that says Rename. Type in exercise-01 with no spaces and click Rename. Click on the name Exercise 01 to navigate inside. Notice the folder icon on the upper right, followed by the name Exercise 01. This is called a breadcrumb. Clicking on the folder icon takes you back to the root directory. Keep that in mind when you're trying to navigate from one folder to another. The breadcrumbs help you to understand which directory you're working in. Okay, so make sure you're back in Exercise 01 folder. This is where you're going to save your work for this exercise. Now click on the New button and choose Python 3 under Notebook. You now have a blank notebook in the Exercise 01 folder. To check this, let's return to the Jupyter dashboard and look at our working directory. You should now see a notebook file inside the Exercise 1 folder. It has the file extension .ipynb. If you look at the Running tab on the Jupyter dashboard, you'll be able to see any notebooks that are active. Right now, there is only one. Okay, back to the notebook. The notebook user interface has three main parts. You have the menu bar, the toolbar, and the notebook area which contains the cells. If the cells are inactive, they'll have a blue border. When selected, the blue border turns green. There are basically two types of cells, one for running code and another for inserting text and images. You can change the type by using the toolbar. Let's go ahead and rename the notebook by clicking on Untitled at the top. Enter your initials followed by GSP-318 Exercise 01 and click Rename. The first thing I want you to do is enter a heading. Click on the cell and then use the drop-down menu on the toolbar. Change the type to Markdown. Type in a $, followed by a space, and then type in Exploring Python with Jupyter Notebook. Click the Run button on the toolbar. The single pound sign designates a heading 1 style. 2 pound signs make a heading 2 style, and so on. Okay, so now let's add more to the notebook. Double-click the heading to activate the cell, and go to the end of the line and press Enter. Type in 2 pound signs, a space, then Geospatial Programming 1. Go to the end of the line and press Enter. Type 3 pound signs, followed by a space, and then your name and today's date. Once you're ready, go ahead and click the Run button on the toolbar. Because Jupyter Notebook works like a web page, you can modify the type using HTML markup. You can even include some multimedia on the page, such as images and videos. For example, suppose I wanted to change the H1 heading to a blue color. What I can do instead of using the pound sign, I can use HTML and an inline style. Go ahead and try it yourself. If you don't like blue, you can choose a different color. Just be sure to add a blank line between the H1 markup and the H2 pound signs. Now let's try placing an image from the web. Open a new tab and Google your favorite wild animal. Find an image you like. Copy the image address. This should be a direct address to the image and not the web page. Return to the Jupyter Notebook tab. In the next cell, change the type to Markdown and enter the following HTML code. Open angle bracket, IMG, space SRC equals, open quotes, then paste the image address, close quotes, close angle brackets. Once you're ready, go ahead and click the Run button on the toolbar. Your notebook should now include a picture of your wild animal. Okay, let's create a new section. In the next cell, create another H2 heading titled Basic Input and Output. Python comes with some built-in functions. One of them is the print function. Just so you know, the print function in Python prints something to the screen and not to your printer. Leave the next cell type as code and type in print, open parentheses, open quotes, hello world, exclamation point. Notice how Jupyter helps you out a little bit by automatically including the closing quotation mark and closing parentheses. You can run this cell by clicking on the Run icon to the left of the cell. The output appears below. This is the advantage of Jupyter Notebook. You can immediately run a piece of code and see the results. You can create another cell below by going to Insert, then Insert Cell Below. This will create a new cell below the current one selected. Let's try some more code. Type in your name in lowercase and as one word, followed by equals input. Then add opening parentheses, followed by an opening quote, and type in what's your name. Go to the end of the line and hit the return key to create a new line. On the next line, type greeting equals, then open quote, hello, comma, space, then open curly braces. It should automatically include the closed curly braces. Follow that with an exclamation point, and then jump outside of that closed quotation and type in a space, then dot format, open parentheses, your name. Go to the end of the line and hit the return key to create a new line. Type print, open parentheses, greeting. Go ahead and run this cell. You'll see a prompt asking, what's your name? Go ahead and type in your name in the box and press enter. Notice that after the prompt, what's your name, there's no space between the question mark and my name. Let's go ahead and fix this by adding a space in our code. For the input function, just add a space right after the question mark and then rerun the cell. There, that looks better. So you see how easy it is to check your code and then test it out? Next, let's try some basic math operations. In another cell below, create another H2 heading called Basic Math Operations. In the cell below, type the following code. A equals 9, B equals 10, C equals A plus B times 10. Print C. What do you think the results are going to be? Let's find out. I get 109 as my result. Was this the result you were expecting? The result was 109 because of something called order of operations. Multiplication and division take precedence over addition and subtraction. What this means is that Python multiplied b times 10 first and then added a. b times 10 is 100. 100 plus a, which is 9, gives you 109. Suppose you wanted to add a plus b first and then multiply the total by 10. You can do this by using parentheses to indicate the order of operations. Edit the code, and this time surround a plus b with parentheses. Now when I run the code, I get 190. Whenever you're working with math, be sure to use parentheses so that you have a clear order of operations and don't run into any surprises. Jupyter autosaves your notebook as you work, but you could also download it in other formats. I want you to download this notebook as an HTML file so that you can turn it in later. From the File menu, choose Download As, then HTML. It should go straight to your download folder, but you should make a copy of the file somewhere where it won't get lost. You'll need to turn in this file later. Back on the Jupyter Notebook dashboard, click the Quit button and close the browser. If you're working on the HSU virtual machines, be sure to back up a copy of your GSP 318 folder to Google Drive before you log out.
Don't forget to subscribe to this channel for more videos and tutorials related to geospatial science.